Hello guys, in this video I'm going to teach us about contactors in a way we are going to clearly understand. I will show you how it is wired, the principle of operation, its uses and everything. All right, over here is a circuit breaker. I'm going to compare this to this so you can understand better, and at the end of this video we are going to construct a simple control circuit using a contactor. Now, what is a contactor? This is simply a heavy-duty switch, a controlled heavy-duty switch used for control circuits and automation. All right. While this, on the other hand, is a switch and a protection device. The switching is completely manual, is a manual process, but the protection can be automatic. Let's say there is a fault condition like short circuiting of any of these terminals. This is the supply terminal, while this is the load terminal. If anything goes wrong here, the circuit breaker can automatically trip. All right. Now, we are going to look at a few similarities between a contactor and a circuit breaker. This is going to help us understand better. So the similarities we have here, you can see L1, L2, L3. These are the input terminals of this contactor. We have T1, T2, T3. These are the output terminals or load terminals of this contactor. So it's a three-pole contactor, input and output. Then a circuit breaker on its own has input and output, just like this. Okay, it has this is 4-pole input and 4-pole at the load. All right. While you need to manually switch this on for power to flow from the input to the load, this contactor does not work that way. If here is energized with live and neutral or L1, L2, L3 for three-phase situations, there will be no power here until the contactor is energized. There is no manual way of energizing it. Rather, it is energized electrically. If you look closely, we have A1 and A2. These are the coil terminals of a contactor. So for this contactor to transfer power from the input side to the load side, electricity must be supplied here, live and neutral. The moment you transfer, you supply here, live and neutral, this contactor will energize and power will flow from here to here. As you can see, there is power at the input terminal of this contactor, but it can't get to the load because the contactor is not yet energized. To energize the contactor, we have to supply the A1 and A2, which are the coil terminals of this contactor. In my own case, I'm going to supply A1 through a switch and supply A2, which is neutral, directly. After this, we run and see what happens at the load. So here must be energized before power can flow from the input to the load. While in the case of a circuit breaker, if we have power at the input terminals, it must be manually switched before power can flow from here to the load. All right, I hope we understand that. That is for the coil terminals. Now, if you look closely, we are going to see other labelings here. You can see NEO, and down here 13, 14. NEO means normally open. Normally open means it's like a switch in the off state. There is no continuity between terminal 13 and terminal 14 when the contactor is not energized. In the ordinary state, here and here is open circuit. That's the meaning of normally open. You can see NEO and you can see NEO here. Now the next contact we have is NC 21, 22. What NC means is that under normal circumstances, without being energized, there is continuity between this point and this point. All right, it's like a switch in the on state. So here and here has continuity when this contactor is not energized. Remember, energizing means supplying the A1 and A2 terminals, the coil terminals of a contactor. So what now happens when you energize these terminals? If you supply live and neutral here, the normally open terminals will switch to become closed. Now, let us demonstrate normally open auxiliary contact. Remember, they have no continuity unless the contactor is energized. So I'm going to supply neutral and live to this extra bulb, but the neutral will come through the normally open contacts. Unless the contactor energizes, the bulb will not receive neutral. So let's go, guys. I've supplied neutral to the normally open contact. Then I supplied live direct to our bulb from the source. Then from the second normally open contact, I'm going to supply neutral to the bulb. Now, let us run this circuit and see what happens. The moment we energize the contactor, the bulb turns on because the normally open contact is now closed. If we de-energize the contactor, the contacts become normally open again and the light turns off. The normally closed terminal will switch and become open. Now, let's confirm the normally closed contact. Remember, the normally closed contacts have continuity, all right? So it's like a switch in the on state. Now, I'm going to supply the extra bulb with neutral through the normally closed contact. All right? Now, I'm going to supply live direct from L1. Good. So with this, we are going to run and see what happens. You can see that the contactor is not energized, but the bulb is glowing through the normally closed contact because it's like a switch in the on state. So as soon as we energize this contactor, the normally closed contact will become open. Let's see. All right. If we de-energize the contactor, it will become closed again and the bulb will turn on. If you remove the energy from the coil, it will go back to its original state and become normally open and normally closed. So we have this arrangement for automation purposes. When we are going to construct our control circuit, we'll build a control circuit for motor control. Then you understand the importance of some of these auxiliary contacts. That being explained, we are going to build a simple control circuit, motor control circuit, using a contactor and switches to help us understand the power flow from these input terminals to the load, the energizing terminals, that's the coil terminals, and these auxiliary contacts. We're going to put all these contacts into use in order to understand how a contactor works better. Let's go, guys. Let's wire this simple electric motor control circuit. Observe what happens when I press the start button after wiring. The contactor has been energized. Now, let us run the circuit and see what happens. First, I'll on the breakers. Now, I'll click the start button. Do you observe? If I release the start button, the motor stops to spin. But if I press and hold, our motor is spinning. If I release the start button, it will stop spinning. This is not correct. All right. So we are going to do something called latching in order to make it start and hold. All right. Let's go, guys. Now observe. You see, the motor is running smoothly. Now let's test the stop button. This is the advantage of auxiliary contact, the normally open contact. If you got value from this video, please kindly like, share and subscribe. And if you have any question at all, do let me know in the comment section. Thanks for watching and see you in the next one.